we know that the difference in electric potential between copper 2 plus and zinc 2 plus is equal to RT ln K over 2F, and we can measure this with a potentiostat or a voltmeter. That would give us E naught of the cell, not meaning that these are standard conditions. So each of these values you get from the table, standard values. So the E naught of the cell equals to RT ln K over 2F. Now you've learned in previous courses that delta G naught R overreaction equal to minus RT ln K, right? So minus RT ln K, so I can now rewrite this into minus delta G R naught over 2F, right? Because RT ln K minus RT ln K is delta G naught R. I just add the minus, the delta G, so I have this term, similar to this term, right? These are all at standard conditions, right? Not A naught of the cell, delta G naught R, these are standard conditions, where activities of zinc 2 plus is 1, activity of copper 2 plus is 1, activity of the copper is 1, activity of the zinc metal is also 1. So what if the system is not at standard condition? Okay, if it's not at standard condition, then you have to go back to the expression of delta G R equal to the delta G R naught plus RT ln activity of zinc 2 plus over activity of copper 2 plus. Right, so simple math trick, you multiply this by minus 1 over 2F, so this becomes minus delta GR over 2F minus delta GR naught over 2F, and this becomes minus RT2F ln activity of zinc 2 plus or over activity of copper 2 plus. Okay, so delta GR naught over 2F is E naught of the cell. It's from here, right? And if you're not at standard condition, then you are moving away from the E naught of the cell by a factor of this term, RT2F ln zinc 2 plus over activity of copper 2 plus. And if this is the E naught of the cell, so this has to be the E of the cell when you're not at standard conditions, right? This is E cell at this is E naught cell at standard condition. This is not at standard condition, right? And the E of the cell deviates from standard condition by this term, by that term.